MS Ramaya University of Applied Sciences.
Hi students, let us discuss FSK scheme. The aim of the experiment is to study of frequency shift keying scheme. Frequency shift keying (FSK) is a frequency modulation scheme in which digital information is transmitted through discrete frequency changes of a carrier signal. The technology is used for communication systems such as amateur radio, caller ID, and emergency broadcasts. The simplest FSK is binary FSK or BFSK. The FSK mode was introduced for use with mechanical teleprinters in the mid-1900s. The standard speed of those machines was 45 baud, equivalent to about 45 bits per second. When personal computers became common and networks came into being, this signaling speed was tedious. Figure 9.3 shows FSK modulation waveforms. The apparatus required are Syntec 2156 and 2157 kit with power cords, digital oscilloscope, probes, and connecting cords. This is the connection diagram. The procedure is connect the power supplies of Syntec 2156 and 2157, but do not turn on the power supplies until connections are made for this experiment. Make the connections as shown in figure 9.4. Switch on the power. On Syntec 2156, connect oscilloscope channel 1 to clock in and channel 2 to data in and observe the waveforms. On Syntec 2156, connect oscilloscope channel 1 to NRZ and channel 2 to output of summing amplifier on Syntec 2156 and observe the waveforms. Adjust the potentiometers of both the modulator circuit 1 and 2 on Syntec 2156 to adjust the amplitude of FSK waveform at summing amplifier's output on Syntec 2156. On Syntec 2156, connect oscilloscope channel 1 to NRZ and channel 2 to output of comparator on Syntec 2157 and observe the waveforms.
Hi students, current experiment is frequency shift keying modulation and demodulation. Apparatus required for this experiment are Syntec board 2156 and Syntec board 2157. In this board Syntec 2156, here we are going to generate data with different line coding schemes. After that we are using FSK. For the FSK we need to use two frequencies for digit 0 and digit 1. I am using 960 kilohertz for the digit 1 and 1.6 megahertz for the digit 0. Here we are combining these two frequencies, one for the carrier modulation 1 and the carrier modulation 2, and we are summing up the two waveforms and generating the frequency shift keying waveform. Here comes the demodulation. FSK demodulator, we pass the FSK modulated waveform through the FSK demodulator detector and then low pass filter it and then pass through the comparator. We are going to get the output waveform which is demodulated. Digital oscilloscope. This is digital oscilloscope. Main power switch of this digital oscilloscope is this one, and we have two channel this is a two channel oscilloscope, channel 1 and the channel 2. These are the magnitude adjusting knobs and these are the horizontal position adjusting knobs, and this is the time scale adjusting knob. These are the connecting probes for digital oscilloscope and these are the connecting wires for the Syntec 2151 board. Let us start the connections for FSK modulation and demodulation. Connect the clock output to the clock input. Connect data out to the data in then connect NRZ low to the signal input, then connect the signal input to the data inverter input, then output of the data inverter is connected to the signal input of the modulator circuit 2. Then connect the 960 kilohertz modulation signal to the modulator circuit 2, then 1.6 megahertz signal to the carrier modulator 1, then connect the output to the input of the summing circuit and the other output to the input of the summing the amplitudes. Here output of the FSK modulated is connected to the input of FSK detector, then FSK detector output is connected to the low pass filter input, low pass filter output is connected to the comparator input, and then create a common ground by connecting the grounds of board 1 and the board 2. Connect the probes for the channel 1 and 2 of the oscilloscope. Channel 1 is connected to the NRZ data and negative is connected to the ground. Channel 2 is connected to the output of summing amplifier and to the ground. This completes the connection. Now let us switch on the power supply of both the board as well as the digital oscilloscope. Let us go for the auto set option, then press the run and stop. Now we can observe there are two frequencies in the sine wave. For the logic 1 the higher frequency, and for the logic low lower frequency sine wave, so that frequency shift keying, it says that there are two frequency, one for the logic high and one for the logic low, that we can observe in this waveform. That is for the logic high there is a high frequency waveform, for the logic low there is a low frequency sine waveform. This is the frequency shift key modulated signal. Now we are going to connect channel 2 to the FSK demodulator output and the negative to the ground. Now again press the auto set option and run and stop. We can observe here this is a low pass filter. Low pass filter is passing the particular one frequency only, other frequency is suppressed, so the envelope, so it's detecting only the logic 1 envelope only, and logic 0 is suppressed. Again here I am connecting output of the filter, output of the low pass filter. So again you press the auto set and run and stop. Here you can see the envelope, smoothened envelope of the previous waveform, such that there is a high in the magnitude wherever the logic 1 is there, and low in the magnitude where logic 0 is there. If I pass this waveform through a comparator, you will get the completely demodulated waveform. I am connecting now this to the, I am connecting output of the comparator and the negative to the ground, and now auto set the oscilloscope and press the run and stop button. Now you can see the transmitted bits and the received bits, they are similar. This completes the frequency shift keying demodulation part.
At MSR, you mark your imagination.